Thanks for bearing through the technical difficulties. We do a lot of crazy things with software, but displaying things is hard. Anyway, I'm William Horton. I'm here today to tell you you can do deep learning. And the first question you might have when I say that is, what are we going to be building today? What does it mean to do deep learning? If you're familiar a little bit with the headlines around deep learning and AI, you might be thinking we're going to build something that looks a little bit like this. If that's what you came expecting, I have some bad news. You're not going to learn how to build a Terminator today. I'm not going to be offended if you decide to leave. So what are we going to be building? Today we're going to be building an image classifier, which I like to say is the hello world of deep learning systems. It's a project basically that can take in images like these and classify them, say this is a dog, this is a cat. So that's kind of what I'm going to be walking through today. And I think an image classifier is a great place to start learning deep learning as well, because it was one of the first places that deep learning truly shined. So this is a graph of performance on this one competition called ImageNet. And you can see that there's been a lot of progress in recent years. 2011 was pre-deep learning, and you can see a drastic fall in 2012 and then continuing on. And this is measures of error rates. So you see the error rates actually have fallen below human level in labeling images. So this is not only a good project to start with, but also a place where deep learning has really shown its ability. Of course, deep learning is applied in a couple of other places. Google has moved over largely to using neural machine translation for Google Translate. And so that's translation using neural nets. And then also, you've probably heard of AlphaGo, which incorporated some elements of deep learning into its system to achieve beyond human performance in the game of Go. Before we get too far into it, let me introduce myself. That's me. So I work as a backend engineer on the data team at Compass, which is a tech-enabled real estate brokerage in New York City. I largely work with Python. Python has been the one constant throughout my career. I've done some things with JavaScript, Node, written a little bit of Go, but Python's been there every step of the way for me. Python's been good to me, so I'm excited to be here at a Python conference to talk to you. And today I'm talking about deep learning, which has really been kind of a passion of mine in the last year. I've spent a lot of time learning deep learning, and that means I've gone through a lot of different resources online. You might be familiar with some of these. You might have used some of them in your own programming journeys. And that's part of why I want to give this talk today, is because there's so many resources out there that want to teach you machine learning, want to get you into deep learning. And over the last year, I've gone through all of these, and they're all great, and they all can teach you good things at different stages of the journey. But what I think sometimes is lacking is to give you one path in, to give you some concrete thing you can do and say, I've learned something, I've accomplished something. And so hopefully today, you'll leave thinking you can build a project, a deep learning project, and know where to go from there. So let's dive in. And to start, we're going to talk about Rails. And you might be surprised to see that up there. This is a Python conference. This is a talk about deep learning. Why are we going to talk about Rails? We're going to talk about Rails because Rails was one of the first technologies that I learned when I decided I'm going to do this engineering thing. And the reason why I want to talk about it today is because before we can talk about deep learning, I think we just need to talk about learning. And the reason that is because I think more than a lot of other technical topics, deep learning comes with a lot of roadblocks. Deep learning comes with a lot of gatekeepers. So there's going to be things in your head that are telling you I can't do this. There's going to be external pressures, people out there saying that you can't do it. And so that's why, again, we need to talk about learning first. What is the process that we can come to learn these difficult technical subjects? So we're going to talk about Rails. But since it's Python conference, if you need to, if you're more familiar, you can substitute in Django every time I say Rails. I recently learned Django. It fits for what I'm trying to say. So this was my first exposure to Rails. And my experience building web applications before I encountered this video was my college final project in Intro CS, I was trying to put together a web application. I was using PHP. I was trying to run MySQL. These are all things that were pretty foreign to me. And trying to glue it all together, it took hours and hours working in the library, in the dining hall, talking to people, trying to get it to run. You might have had an experience like this, maybe learning something. And then I encountered this video. And this guy who created Rails, his name is, I can't pronounce that, DHH is what he goes by. And he said, I'm going to show you how to build a blogging platform in 15 minutes using this framework. And for me, that was like amazing, because I'd spent so many hours building my first web application. Then I encountered this. He's like, I can do something better than that, something cleaner than that in 15 minutes, and it works. And so that was an incredible experience. And that inspiration is part of what has driven me to go down this journey into programming. And I think part of what the magic of it is that it's so simple to get started. So these are the commands from the Rails tutorial. Django on the other side for Django people. So you just install it, gem install Rails. Rails new is the command to start a new application. You go into the folder. You can run the server. And what do you see? You see this. This is like such a great moment. I remember the first time I ever saw a screen like this. And it was incredible. It's like, wow, I did something. Like there's a server on my computer that's serving up HTML. I don't even know what all those things mean, but I can see this in my browser. Like that's amazing. And the Django one looks like this, which is also cool. There's a little rocket ship. Congratulations. These experiences are so great when you're starting out, because you feel like you've accomplished one thing. You feel like maybe you spent hours setting up your environment and figuring out how to install packages, but finally you get here, and you're like, I can keep going on. Like this is something that I've done. This is great. And I mentioned a term previously, which is magic. And I think we need to take back the term magic. I think when programmers say something's magical, it has a negative connotation. It's like, oh, well, they're hiding too much behind this, and it's going to come back to bite you in the end. And I will say, anybody who's built a complicated Rails application can tell you maybe some of the abstraction does come back to bite you in the end. But I don't think we should overlook the power of these experiences for people who are just getting into it. For people to have this magical experience and say, this thing just works. And you're going to spend a lot of time trying to figure out how it works in the future. But to have this moment, to see this screen and say, congratulations, yay, you're on Rails, like you can't replace that. And so I think that that's a mindset we need to be in when we're talking about starting out in these fields, tackling these topics, is how can we give people this experience? How can we get people excited about what they're learning? And so now that we've talked a little bit about learning, I'm going to go back to talking about deep learning. And so I mentioned there's some roadblocks, some gatekeeping. And so what are the common ones when it comes to deep learning? One common one I hear is, what about the math? I was brainstorming this talk, and I was like, I want to present deep learning to people who maybe know a little bit of Python, want to get into this. And someone said, how much math do I need to know? And that's a big question. That's a question people ask. And the question is, enough math to get the answer is enough math to get it done. And we'll talk a little bit about that. But this seems to be a common question people have. This is one that I fell into when I started learning deep learning, is you feel like you have to learn everything about everything before you even let yourself start. And I think this happens a lot. It's like you feel like you're not even giving yourself permission to do it before you think you can do it perfectly, before you can do it exactly right. And so this is another common roadblock that people run into, especially in deep learning, because like I said, there's so much information out there. There's so much research going on. Things are changing so quickly. If you try to do this, you're never going to let yourself actually build anything. And then this is another thing, is thinking you don't have the right credential, thinking you don't have the right background, thinking you're not allowed to do it because you don't have a PhD. And so these are things I want to break down and say that you're allowed to do it. You know enough to do it right now. And so I'm hoping to put these tools in your hands so you can build a deep learning project today and get that first experience down the road to learning. And for me, this is kind of what bumped me in that direction. I'd been spending, probably when I encountered this, a couple months doing some online tutorials in deep learning, but not really giving myself the opportunity to actually build something and run it and see how it works. And I found this video, Fast AI, and something really clicked for me. Just the way that the teacher, Jeremy Howard, presented things, he said, I'm going to show you in like a 30-minute video how you can build, it's actually an image classifier. This is a great thing to start with. And it was similar to the experience I had with Rails. It was like, one, you're allowed to build this. You can build this. In a short amount of time, I can teach you how to start moving toward your goal, which in this case is learning deep learning. And I fell in love with their approach to what you need to succeed. 95% of it is pragmatic coding, 85% tenacity, 80% an open mind, and 60% was high school math. And I was like, okay, I got through high school math. I didn't take any math in college, but I got through high school math. So this formula, I was like, this is something I can see myself doing. And I think hopefully everybody in the room can see, I think we have some tenacity. I think everyone here has an open mind. They want to learn something. And so this was, I don't know, this is so cool to see. And this is the kind of approach that I want to spread to you. So I don't want to overstate the case. Okay, math is important. Once you get further along in learning about this subject, obviously you're going to need to learn some math to do more advanced things, right? Theory is also important. There's a ton of people out there researching these topics. And to really get your system to work, let's say you want to build a production system, right? You might have to dig into more theory. You might have to understand what is the right thing to use when. I mean, that's also true of all coding, right? I mean, you're going to have to dig deeper and deeper the more complicated your use cases get. That's true. But what I want to say today is just get started with what you know. You have a lot of knowledge already. You have a lot of skills. You have a lot of enthusiasm, obviously, because you came to a Python conference. And so that's what I'm saying, is let's get started today. You know, when you run into blockers because you don't know enough math, like there's resources out there to learn the math. But I don't think that should get in the way of getting started. And if you don't believe me, and if you don't believe this online course, I came up with an authority. I found this on the Google blog. And they say, with TensorFlow, you don't need to be knowledgeable about the advanced math models and optimization algorithms needed to implement deep neural networks. So if you don't believe me, Google employs a ton of deep learning research PhDs, and they also are blogging and telling you that you can get started using these frameworks out there. We're not going to be using TensorFlow today, but I think the general idea is there are tools out there that are open source that let you do this kind of thing. So what does it mean to use what you know? What do you already know that can help you do deep learning? And the first one is Python. You're all here. You all want to learn Python. You all might know some Python. And so this is a great thing because Python is becoming the default language of machine learning and deep learning. Most of the tools, I talked about TensorFlow, PyTorch, scikit-learn even. All of these things are written in Python. And so like by just being here, you're like 3 steps ahead. Like by knowing Python, by working on Python, you're like ahead of the game. This is another thing that you might have some experience with. This is like the dreaded Jira ticket. If you know what this is, I feel sorry for you. This is a Jira ticket or maybe like a mock-up. And what this is supposed to show is you might already know how to turn ideas into working code. I mean, that's the basis of programming. And what I'm trying to say is that this isn't any different when you get into deep learning. It's just a different domain. But people are going to express ideas. People have written algorithms, maybe written diagrams. And in order to build your project, you're going to have to turn those diagrams, those written instructions into working code. But that's not that different from the things that we already do. So another thing is, so these are documentation pages, GitHub pages for a couple of other deep learning projects. And you might be familiar with reading documentation already. You might be familiar with using GitHub, with reading the source of open source projects. And that's another thing I think that puts you ahead in terms of learning deep learning. That's a skill that you can leverage to be able to do this. You can dive into documentation. You can read the source code. That's another thing that you already have in your pocket that you can pull out when you start learning deep learning. This is a really bad stack trace. It's actually in Java, which I think says something. I couldn't find a crazy-looking stack trace in Python, so I had to pull up a Java one. I don't know what that says. But this is to say, you already have probably spent a ton of time debugging. You've probably spent hours of your life debugging. In a similar way, like when you start working on deep learning systems, this is going to be a lot of what you do. Just like you're going to get errors in your code, things are going to break. You're going to have to figure out why. And again, it is something you can bring over from the programming you're already doing, stuff you already know. And this is the final one, is you probably know how to use Stack Overflow. And honestly, when you're working on something, you're still going to be looking up a lot of things. Maybe not this. It doesn't have a good answer for this yet, but maybe after today I can fill it in. So to put it together, I put together a little demo video, which just shows how you can go through and build an image classifier project like I was talking about before. Okay, so this is a site that you might know, you might not know, but it's called Kaggle. It's a platform for like data science competitions. And this is an environment, I'm going to talk a little bit more about it. But basically, Kaggle has something called kernels, which basically is an environment in which you can write and run your code in the cloud. And so I put together a little bit of a demo kernel to show off the functionality and the code that you would need to write to build this system. And so here you can see it loads the kernel, and then this is a couple things that are important to note when you want to like run this kernel yourself. One is how to add a data set. So you go over here and you can search through competitions. Luckily, there's a cats dogs competition, so I loaded the data from this dogs versus cats competition. And then a couple settings that you need to check. One is to make sure the GPU is turned on. So I'm going to talk a little bit about that. But the GPU is a piece of hardware that's going to make it easy to, or quick to run your code. And then the other thing is to make sure you have an internet connection, because the code needs to download some things. So once you turn those settings on, looking at the actual code here, I'll make it up full screen actually. So you're going to import some libraries. We're using the FastAI library, which is associated with this course that I was talking about. This is important to check. This checks that the GPU is turned on. And then here we're going to define the data. And I've also published this kernel in public, so if you don't catch all of this, you'll be able to read through the code after. But basically, this is the data we have. The file names point to image files, and so that's the input data. So you can see they're labeled like cat.0, cat.1. And then the labels, that's like and then that's the ground truth. So that all the cats are labeled 0, all the dogs are labeled 1, so that the algorithm knows what to train to. And then we define like a few parameters. So we define the architecture we want to use for the model, the size of the images, and then these two pieces are really the main part of the abstraction that the FastAI library gives you. So the first chunk is basically how to work with training data. So we basically pass in the file names as well as the Y variable, or the labels. And this is going to give us basically a wrapper and a lot of utility methods on working with this data during training. And then the second piece here is a learner, or a conv learner. And this is a wrapper around a convolutional neural net. And this, again, like, it gives us a lot of abstraction around being able to train these kinds of models. And I cut out the training part. It only takes a couple minutes. So again, I think this is like something you could do today, but I didn't want to bog down the presentation watching this train for 5 minutes. So there, once it trains, you can see we ended up with a model that almost has 99% accuracy when I ran this earlier today. And that's pretty good for only 5 minutes of training. And then you can actually visualize the predictions of the model. So serialized? Yeah, you can save the weights to your model. Anyway, so you can plot the most correct cats. So these are cats that the model predicted 100% are cats. In the same way, you can predict the most correct dogs. So these are dogs the model knew or predicted with 100% confidence that they were dogs. These are the incorrect ones. So it's interesting. Some of these actually have dogs and cats in the image, so this is a problem maybe with labeling. And that's a whole other topic is, your model is only as good as the data, and how is it supposed to know with that third one, for example, there's a tiny cat and a big dog, but it was labeled as a cat. So, and then here, this is one of my favorite ones. This is a picture of a dog. So it had a little bit of a hard time classifying that. And then this were the ones that was most uncertain for various reasons. So yeah, you can, it's nice, and that's why I like the image classifier model to start out with, because, sorry, let me get back here. Because you can actually visualize the results, and like I said, I think that's an important part, is you can actually say, what is this model doing for different images, and start, once you get into it a little bit more, start trying to understand why it might make those kinds of mistakes. So, like I said, I ran this in a Kaggle kernel. I think this is a great environment to get started building deep learning projects. One, it gives you a GPU, which basically, compared to running it on a CPU, it gives you maybe 100 times speed up, maybe more, depending on the model. And so when you're starting out, you want to be able to iterate quickly, and this really makes a big difference, waiting like 5 minutes to see a new model train versus waiting like hours. That really is not great. I've tried that before. It's not a lot of fun when you're starting out. Data. So Kaggle is a competition platform, and so it's another reason why it's a great place to start out is because it has so much data. People contribute data for the competitions. People contribute data kind of just as open source. And so once you get started, maybe you build this cat dog image classifier, it's very easy for you to click over to a different data set, add a different data set, and with the same code, try to run it on different inputs and see how that works. And that's a great way to start to apply what you've learned. You might have seen this is like a Jupyter notebook interface. And the first time I encountered it, I found it a little bit strange, honestly, because I'd been used to writing Python in Python files. But I think it's actually a great tool, especially for experimental things, and especially when you're starting out, because it allows you to iterate. It allows you to display things interactively. Like I said, you can see those images right there in your runtime environment, and that's something that would be harder to do if you're running it from the command line. And then the other thing is it sets up all these libraries for you, and I can't tell you how big a boon that is, because getting these things set up when I was first trying to learn, I mean, it's painful. And so you can just basically import these. You don't have to make a requirements file or anything. They're already loaded in, and Kaggle maintains like a Docker file of the most popular libraries, so they're already preloaded. I mentioned a little bit about the FastAI library, which is built on top of PyTorch, which is open source framework by Facebook. And like I said, these are really the two most powerful pieces of abstraction that you get from the library. One, you pass in, like I said, the data, which is the names of your the path to your images and the labels. And this does a lot of things behind the scenes to make it easy for you to train over that data, including opening the images, resizing the images. It applies some transforms during training even. And so this is a really powerful abstraction that you get from this open source framework. Additionally, I mentioned the learner. And so this is, like I said, providing you some sane defaults and some helper methods over a convolutional neural network where you can pass in, like I said, the architecture you specified, as well as the data object, and then a few, I mean, that's just where to save the outputs, the models, and the temporary path. And so these are really powerful things. And eventually, you're going to have to dig in and understand how these work. But I think just getting started out, being able to do it with these kinds of libraries that give you these powerful abstractions is a great way to get started and be able to actually build something that you can run in a couple lines of code and train in a few minutes. And another reason why I think it's such a great time to get into deep learning is because there's so many communities, so many places where people are sharing what they know. There's a forums associated with the FastAI course and library. PyTorch, like I mentioned, is the Facebook framework that it's built on. They also have their own forums for discussing the library. Kaggle has discussion threads, and this is one of the most amazing things I've seen, which is people who win these competitions, sometimes tens of thousands of dollars, more than that in prize money, they come back online and they tell you how they did it. They tell you how they won. And it's so cool. You can go into the discussions and see how somebody achieved a state-of-the-art result. Sometimes even running in Kaggle kernels. So sometimes even using tools that you have at your own fingertips. I think that's amazing. AI Saturdays is a recent effort basically to, in a bunch of cities across the globe, teach people deep learning and AI like every Saturday for a couple weeks. So that's something to look into. Medium, there's a ton of great articles. Twitter, and this is just another thing I wanted to mention. As I was working on this talk, Google put out this thing called Seed Bank, and if you look at the benefits it mentions, no setup required, free GPU backend, explore and learn. I think it just goes to show that there's a ton of people out there that are trying to make this style of learning, deep learning, available to people, and I think it's so powerful. And I haven't had a chance to try this out yet, but this is another thing. If you're interested in this, these have notebooks that you can run in your browser that do the computation on Google's machines behind the scene for like common models. So you might be asking now, like I've gone through this, what can you do with what you know? Like maybe you learn a little bit, maybe you learn a little bit about deep learning. You've done a few projects. Like what can you do with it? And so I put up some near-term questions. So once you might be able to run this one kernel that I showed and build an image classifier, things that might point you in different directions to be able to continue learning. What happens if you train it for longer? So I trained it for 2 epochs, which is 2 runs through the whole training data. But this is a question you can explore. What if you train it for a longer amount of time? Does the model get better? What happens if you change the learning rate? So I didn't mention this. This is one of the parameters that I set. But this has a huge effect on how the model trains. And so once you get comfortable with this material, with building this stuff, you could start changing some of the defaults, some of the things that are already set. Can you apply it to another data set? So I mentioned this, but once you can run it on cats and dogs, can you run it on something else? There's a bunch of image competitions in Kaggle, so it should be easy to identify some other opportunities. And can you use a different architecture? So I imported one model called ResNet, but there's a ton of different models for doing this image classification. And so that's another thing that you can experiment with if you get comfortable doing these projects. And then I want to talk about some kind of farther ahead questions of, if you really get into this, if you really start to learn, what can you do? And the one thing is understand, implement, and explain. And so I talked about how the deep learning community is really about sharing knowledge and how there's so many people out there on the internet learning these things and helping make it easier for people to understand them. And so these are a couple blog posts I picked out that I found interesting. And I think it's so cool. Like these people are reading current research papers, adding the code to open source libraries. And I had a chance to do this. So I added something to the FastAI library based on a research paper that I actually found on Twitter. Someone had tweeted, "This is a cool result." And so I read the paper. I replicated the experiments. I added the code to FastAI, and I wrote up a post explaining it. And that was just such a great educational experience. And for me, that's one of the great things about doing this today. Is like there's so much out there for you to take advantage of and learn, and then give back if that's something that you want to do. One other thing I want to point out is win an Emmy. So if you're familiar with the Silicon Valley show, you might have seen the Not Hot Dog program. Anyway, they, like, just when I was working on this talk, found out they got nominated for an Emmy for this app, which is like this. And basically, the joke is, it was supposed to be food identification, but he only got around to training it on hot dog or not hot dog. But this is the post from the guy who actually built this application for Silicon Valley. And the cool thing was, he was a FastAI student. He was somebody who had engineering experience, who wanted to learn more about deep learning. And now he built probably one of the most widely known deep learning applications out there. And I think that's so cool. I think tackle your business problems is another cool thing you can start to do. So this is from the TensorFlow blog on Google. And this is a great article, but it's basically how a Japanese cucumber farmer used deep learning and TensorFlow to sort these cucumbers. And I know that sounds like kind of crazy, but it saved so much time on the farm to use these image classification techniques to be able to sort the cucumbers automatically versus manually. So and I think that's more broadly true, that as these techniques become more powerful and as we put them in the hands of more people, like there's so many opportunities out there to build solutions for businesses and for things that you might be interested in doing. And so I think this is another great result out of putting these tools out there, making something like TensorFlow available, is that people can start solving their own problems once they learn enough. And then this is the last thing I want to mention, is take on the giants. This headline, an AI speed test shows clever coders can still beat tech giants like Google and Intel. Basically, this is a group of Fast AI students who decided they want to enter this Stanford competition called DawnBench, which is basically competing to see who can train these classifiers up to a certain accuracy level in a set or in the shortest amount of time. And so you can see here, basically Google, 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 and then this is Fast AI plus students team. And these are people who don't have any formal training in deep learning, no PhDs. And they beat out Intel. They lost to Google, I guess, but they still beat Intel. And I think that's pretty good. They did end up first on this other competition. And I think this is cool, too. But in January 2018, it took over an hour to train it up to this level of accuracy. And they got it down to under 3 minutes. And that was just progress in 3 months of time in this competition. And I think that's a cool result. And that's something I want to highlight, is this is such a new field that there still are so many opportunities like this. Don't think that everything's solved, because there's people out there working on these things, and they can achieve something like this. And I think that's really cool. So the last thing I have to say is get started. I hope that I've put some ideas out there, some tools that you can use. And like I said, I published the kernel that I used for the demo, so hopefully you can go on. You can fork that on Kaggle, actually, and tweak it on your own. And definitely let me know. This is my Twitter. I'm on there probably too much. Anyway, thank you so much. And yeah, have a good day.